Hi, and this is C123 presenting a tutorial for secure hashing in PHP. And in this tutorial, you'll learn how to hash in PHP securely within 15 minutes. Most people who do hashing or hash passwords these days, they don't use really good methods, or not secure ones anyway. So I'm presenting a tutorial to show you the most secure method for hashing your hashes, or hashing your passwords. Well, we are hashing our hashes in this instance, so yeah. To start off with, you have to familiarize yourself with these functions. We're not going to use all of these functions, but it's good to know them anyway. Yeah, it is possible to do a secure hash purely on SHA-1, and for a good reason too. I'll show you SHA-1 password. Then we do then parts of 8. So if you go 10 in, then 10 from the opposite side, and that will make yourself a secure hash. There's no salts, but still, if the SHA-1 algorithm is reverse or brute force or cracked, it will still be secure, because this substring method or substring function, it pretty much erases part of the original data and makes it impossible to reverse, because let's just run that undefined password. So let's make up a password and echo that. So that's our hash. But say you were to reverse that. To reverse a hash, for those who believe it's impossible, what you do is first you assign it to a variable, so hash, and then you parts, or let's say hex equals be hash. Now SHA-1 does it in parts of 8, so we have to split it every 8 characters along. And for each hex is key val. We only really need the key. Then we can put, now the XMP in HTML is better than PRE, because if you yield any HTML code between those two parameters, then in PRE it'll execute that HTML, but with XMP it won't execute that HTML. But in this case it wouldn't really matter anyway, but yeah. And here's the numbers that the algorithm had output. In the algorithm, according to the university's definitions, this is H0, H1, H2, H3, and H4. And all you have to do on the first part is subtract some numbers from them, and then put them through some massive loops that would take 2 to the 160 Hertz to process, and you'll eventually get your original string. I have worked on this myself, but haven't had the CPU available to do this, but yeah, it is very well possible to do. So that's basically the first stage to reverse a hash, which is all simple and all. But if you want to get fancy with making a hash secure, like adding a salt, salts are pretty much need to be randomly generated. So what you can do is use, say, the CRC32 function. Or yes, then CRC32 you can do a hex to bin, and this will make it on a base 16-bit, which will use the full ASCII table, so it'll use every character there is. And just for your information, see these substrings 10 and -10, when you use them, it'll make it impossible to grab these two numbers as well as these two numbers, which means the user's pretty much left with just this number, and that makes it, well, virtually impossible to reverse the hash, because you need more than one calculation to base triangulation and so forth on. Like, the rule of thumb with triangulation is you need 3 points of vertices, and you can base it on that, and here we've got more than 3 points, so it's easy as pie. And just like pi, it requires infinite CPU, but in this case it's not infinite, but rather a dramatic amount, which in the near future, I'd say 2030 or 2030, the CPU will be available, and that's when I will be running the algorithms to do it. Anyways, that's pretty much how you do a secure hash, and if you want to put it in a function, you can do function true hash. Usually simple is better, because you will want your hashing mechanism to use less CPU, but in saying that, not so little CPU that makes it so easy to brute force. So what we'll do, hex to bin, well, hex to bin isn't always the best option, but I'd say if you want to compact your password, what you can do is here we go, and to generate a hash based upon that, true hash, and your first parameter is your password, and your second parameter is if you want it to be a compact password or to be a hex password. The difference I'll show you. So we'll do one with true. I see we're running out of time here, so I'll make this quick. And if we run that, must be hex bin. What do you know, my library hasn't got it. That's embarrassing. But yeah, in the documentation, if we go to hex to bin, what it does is, oh god, where's an example? Well, it outputs a sort of format. Oh, here we go. Pack. We shall use pack instead. Where is it? Oh yeah, and we gotta echo it. So this here is a binary version, and this here is a hex version. And so basically you can make it shorter for storage capacity reasons. For example, if you're brute forcing and you had the extra bit of CPU, you could make it extra short so that you use less hard drive space, or if you have the extra hard drive space, you can use a full hex so that you save CPU. And so that pretty much concludes our tutorial, and so see you next time.